computers can do something very remarkable that we take for granted every day, and that is they can remember. For example, this laptop, it remembers all the icons that I have, all the apps and programs that I downloaded. But how do computers remember? So let's explore this using logic gates. So this is how it works basically with logic gates. So these are the two NOR gates. This is the output. So if this one becomes high, correct? So if this one's on, it's going to turn this NOR gate on, which then turns the output off. So if this output is off, this NOR gate's going to be on, which is going to come here. So both these two are on right now. But if we take this one off now, this NOR gate's still going to be off because this output's high from the previous circuitry that just happened. And if we reset it, it's going to reset everything. So that's how it works with the NOR gates. So this is the basics of how computers remember. And this is technically a data latch, but to go even simpler, this area right here is an SR latch. And the way it works is there's a set and reset. So we plug the pin in here, we set it on, and now the electronics remembered that we wanted the state on, and it's going to be on forever until we either plug off the power source like this, or we go into the reset pin. So let me set it like that, and then this is the reset pin right here. So now it's off. So this gate is traditionally made up of two NOR gates, but you can make it using only two NPN transistors. And there's a fantastic series that this man made on how computers remember using logic gates, and I'd really advise y'all to check it out if you're interested to see how it works using logic gates. But I'm more interested with how does this work with only two transistors, because traditionally it's going to work with two NOR gates. And I'll do a little explanation here, but like I said, please go check out the other guy's channel if you're really interested with how it works using logic gates. So this is how the SR gate works with transistors. So bear with me because this might get a little complicated. So when this area is hooked up to the ground, so these inputs are kind of opposite. So once they're hooked up to the ground, that's kind of inputting the signal in. So when this side, let's go with this side first, is connected to ground, this 5-volt source goes through this resistor, travels up, goes through that resistor right here, and goes immediately to the ground. So this resistor right here can't go through this gate because the current's not going through, it's going here all the way up to the ground because that's the path of least resistance. So this current is forced to come through this wire, jump over this cable right here, into this resistor, and then into right here, and it opens up this gate. And then when it opens up this gate, current can start moving through there like this now, because now the path of least resistance isn't through the 220 kilo ohm resistor, it's just through the transistor itself, which opens up that gate. And the same thing's on this side. So when this side is closed, the current travels through here, and then it travels through here, so this gate's closed, and then this gate alters the path of least resistance for the electrons, and then this one opens up after. That's how it remembers it after, because once the gates open up, then the path of least resistance becomes very obvious, I guess, for the electrons, you could say, so they just go through that after. So that's pretty much how these SR gates work. We're gonna have more gates coming up in the future because I want to make a transistor-based digital clock. I think that would be cool. So future episodes, we're gonna have hopefully a binary to numerical converter with transistors. We're gonna also have a data bus connected, and then we're going to connect the ALU that we made in either a previous episode or in the future episode, depending on what order I post this in. Connected that up to the data latch that I made, so it can remember the previous number and add 1 to the next one. So this is a big project, it's taking me a long time, so stay tuned to watch it.